Good evening, Dr. W. This is Natsanet Marga. Just gonna start to Unit 2 video, chapter 4 to 6. I'm gonna start, sorry, read the question first. Answer the following questions using videos and post your responses to the appropriate folder in D2L assignment. Be sure to read each question carefully so you answer all parts. Isomers are compounds with the same molecular formula but different arrangement of atoms. For each type of isomer listed below, draw an example pair of molecules that fits the definition using skeletal structure and with dash notation as needed. Then explain each of your pairs using the definition of each type of isomer. My answer is pairs of structure isomers. Structural isomers, also known as a constitutional structural isomer, also known as a constitutional isomer. Two or more organic compounds have the same molecular formulas but different structures. For example, butane are structures C4H12. Its butane structure, this kind of using structural condensational structures, and then here to the same thing in condensational structures. Both structures the same molecular formula C4H10, but the left is the straight chain alkane butane, the right branched chain. The left structure has 4 carbons bonded in a row, while right structure has 3 carbon bonded in a row. 1 carbon branching off the center carbons. I using for both of them the same molecular formula, this kind of like the same times I do in structural skeletal structures. Both sides, one of them row, the same line row in carbons, the other one in the same line, 3 of them the same line, one of them in branch. I go in number 2, it's B. Pairs of conformational isomer. Pairs of conformational isomer is both structure have the same 4 carbon chain. The same 4 carbon chain, but the atom in the chain are not arranged the same page. For example, I using the same line of row in the carbons and hydrogens. The other side, I using 3 carbons, the same row, 1 carbon in the branch, and even I drawing the skeletal structures. I don't have to up and down, just straight for drawing. 1 go down, 1 go up, the same finger. I didn't use it anywhere. The same thing in here, just go down and then go up and then go up. Only one side of 1 point of fingers. I didn't change the lines. I go in, see pairs of cis-trans isomers? And my answer is pairs of cis-trans isomer when two molecules have the same molecular formula, the same attachment to the carbon skeleton, but a different spital arrangements. The stereoisomers with the methyl on the same face of the cytopentane ring, both on bottom. This case called cis stereoisomer. That means the same side is cis isomer. On methane are on top face, and the second on the bottom face is called trans isomer. For my example, we have two cis isomer and trans isomers. Cis isomer, we have double carbon, bonded carbon, and then I have carbohydroxide, both sides. The face is in up the same side. In the other side, trans isomers, I have in carbohydrates and hydrocarbons. It's one of them in top, one of them in down. So that means trans isomers. I'm going to back pairs of enantiomers D. Pairs of enantiomers is compounds which have the same molecular formula and the same connectivity, but are non-superimposable mirror images of each other. Belongs to stereoisomer is called enantiomers. Enantiomers are mirror image of each other. For example, my shoe are one example. My shoes looks very much the same, like my pair of shoes looks the same, very much the same, but not identical. For example, pairs of glove. In the pairs of glove, we have in right and left sides. I use in right sides to right hands. It's properly entering. I use in right side to in left side not properly entering. So the same kind, like the same, they look like the same, but we using too properly. For example, carbon here we have in COOH, carbon hydroxide, hydrogen, H3C. The same in mirror. It's it's not identical. The same in mirror. HOOC, carbon, hydrogen, HOCH3. I'm moving to number 2 questions. There are many ways to classify chemical reaction based on patterns and common characteristics for each of the types of chemical reactions listed below. Write an example chemical equation showing reactant and product structures. Then explain how you classified each of your chemical equations using the definition of each reaction type. A. Synthetic reaction. A synthetic reaction is a reaction that occur when two different atoms or molecules interact to form a different molecule or compound. Formula: A plus B equals AB. So the synthetic is, it's different reactions that occurs when two different atoms or molecules interact to form a different molecule or compound. For example, A plus B, AB, carbon plus oxygen, carbon dioxide, to get in carbon dioxide, to magnesium, it's we have in solid, plus oxygen, it's gas, when in the magnesium it's warm, add oxygen equals too hot, sorry about that, the magnesium it's too hot, plus oxygen is a gas, combined together to magnesium oxide, solid. We got in the result in solids. B, the question B, decomposition reaction. Decomposition reaction, we take a compound and break it down into atoms or molecules. We call that decomposition reaction. Formula: we have in I using the same formula in synthetic. I starting to atoms to interact different molecules or compound. In here, compound to molecules or breaking down molecules or atoms. Compound C, maybe it's C, like example to A plus B. To magnesium oxide, solid, it's a result. This is a compound to break down to magnesium solid plus oxygen gas. It's C, oxidation reaction, reduction reaction. Oxidation reduction reaction is oxidation reduction, called redox reaction, can be identified one of two ways. They have in two ways. They contain metal ions and involves the exchange of elements inorganic, or they can involve the addition or removal of oxygen or hydrogen, or is organic. Oxidation and reduction always occur together. One substance always occur together. One substance oxidized the same time other substance reduced. Examples of oxidation reduction or redox is sodium plus chlorine, sodium chloride. The ionic compound of sodium chloride is sodium, if one chlorine take in gain in one. For example, that it's the examples of the I use in this method. I use the methods oily rig. The sodium oxidation is loss. The oil rig means oxidation is loss, reduction is gain. It's gain of electrons. It's sodium gives 1 electron, so chlorine, it means loss of electrons, it's using sodium plus. Chlorine gain 1 electrons. It's gain of chlorine, it's gain of 1 electrons. It's chlorine minus. I going to D. Hydrolysis reaction. Hydrolysis reaction is the cleavage of chemical bonds by the addition of water or a base that supplies the hydraulics ion OH minus, or hydrolysis means OH. Hydrolysis means, hydro means water, lysis means break, where water is consumed as a reactant and the reactant molecule is split into 2 smaller molecules. Hydrolysis of acids. Sulfurous acid plus water, it gets H3O plus HSO4. And I'm going to E. Hydration reaction. Hydration reaction is the addition of water to the double bond in an alkane. The water gets adds as H and OH. This reaction often requires a catalyst, such as an acidic or an enzymes, carbon CH3, CH2, CH, double bond, CH2, we got in acid H2O. I turn to number 3. Answer the following about the disaccharide maltose. How is maltose commonly produced and what is it used for? Maltose is produced by the enzymatic hydrolysis of starch, a homopolysaccharide, catalyzed by the enzyme amylase. Maltose is used for medicine, uses for dry mouth. For some reason, or maybe it's happened something, the dry mouth, it's happening. The maltose they're using in medication to give in, like the medication to use in process to medication to dry mouth. That's it's to used in maltose. B. Draw the structure of maltose. I draw the structure of maltose in here. Glucose, we are having the chemical or molecular formula of maltose is glucose. Both glucose is in maltose. I drawn the structures. See on your structure. Label the glycosidic bond, then name the glycosidic bond. I labeled the glycoside bond. It's 1 in here, 4 in here, 1 for glycosides linkage. In D, draw a hydrolysis reaction of maltose to form 2 monosaccharides. I drawn in monosaccharides to 2 glucose. It's this one for in glucose structure. I use in hydrolysis both reactions. In here H2O, this means in hydrolysis I take in both this one or in hydrolysis reaction of maltose. Thank you for giving me this chance, Dr. W. I don't know, I explain as soon as I can. If you have any questions, or if you need do again, I can do that one. More explanation, a little bit confusion. The second time I'm doing for this kind of test. In again, I just show you I just I just take a picture for the questions and my answers starting to one. Okay, all questions in here